verifying, by doing your R1, R2, we're verifying that we have continuity of that CPC. Because if it wasn't continuous, we wouldn't get a low reading, we'd get a high reading, wouldn't we? We want to confirm continuity of that CPC. You've partially said you've got continuity of the line conductor as well, haven't you? Right? But you will definitely confirm that when you do your R1 and your RN as well. That will completely confirm that. But we're more concerned with our CPC because that's our safety circuit. Without that, you might as well forget doing the other tests. Right? I always do an R1, R2 or an R2 test first. If my CPC conductors, right, are not continuous, stop, the circuit's failed. No point in doing all the other fucking tests and then going, yeah, I failed this circuit again, but I've done all the insulation resistance tests because they're going to be wrong anyway. Okay, it's failed. When it's put right, then you can come back and test it and carry on with the other tests. If you carry on and do all the other tests because that's failed, your tests are irrelevant. You're just wasting your time. Wasting your time. So don't be afraid to, that's failed. And I'll just stop and I'll go and say, you know that circuit's failed, I'm failing it. I'm not even bother testing anything more on that circuit, it's failed, mate. That's it. I'm now going to disconnect it, you can't use it until it's rectified. No CPC on a circuit, that's a C1. Immediate danger. Immediate danger. You've got no protection on it. It will not disconnect. It's as bad as a fucking great hole that you can put your hand in and grab hold of a buzz bar. Right? It's as bad. If you've got starters, time switches, electronic components, all these little things, anything that's got some sort of relaying or a live to neutral link or a coil, right? Because a coil with live on one side, neutral on the other, will change the resistance. So they need disconnecting or bypassing.
How do you bypass it? Just out of interest.
How do you bypass it? You can link in a stop-start button. You can link straight across. Right. You just link across, and
so
it will just
like
ignore
a switch or a timer or something.
Yeah, yeah.
What would you do on the, like, you're testing a house and it's got the old, really old wiring where the lights never used to have an earth, and there was just old black and
What?
white.
And you're going in to test it?
Yeah.
As long as nothing has changed since the day of installation, then that's fine.
Yeah.
Right? But as soon as somebody's changed one thing, right, a fucking lampshade, no, not a lampshade, but if they take the ceiling rose down and put a new ceiling rose up, right, that's it. It's got to have an earth on that circuit. That's it.
Yeah.
My house was built, no earths on the lighting. No earths on the lighting. And I just got up with a fucking single core cable and run it round all the frigging lights and connected it up. That's it. Right? If you haven't got an earth, it will not disconnect. It will disconnect on overload because your load is between live and neutral, isn't it? Not live and earth, it's live and neutral. That's why an MCB works on load. Okay? But if you've not got an earth and you get a fault, well, it's not going to be a fault because it will just make things live that shouldn't be live. That's what your earth's there for.
Is that why that they brought out all these class 2 things that have no metal content in there at all?
What, the consumer units?
No, the lighting.
Oh, the lighting. Most of the lighting now you put up, a lot of it now is class 2.
Yeah.
Yeah, I mean, it's double insulated, it's class 2, it's
Yeah.
very safe. You still run an earth for the circuit. Well, you've got to have an earth in for the circuit to start with anyway,
Yeah.
in case it's changed for a metal fitting.
Yeah.
But yeah, most of it now is class 2 because too many people are getting fucking shocks off lighting.
Don't you put it in a connector block though?
Yes, you just put it in the connector box and leave it there.
Yeah.
That's it. Anybody in their house got these, what we call the punk waller fans, the ones that spin round, the big ones?
Yeah.
Yeah? Right, I had about 3 or 4 of them in my house and I nearly got rid of the wife. I checked the insurance policy first, but they're metal cased, right? And they never spin properly. They've always got a little wobble on them, haven't they?
Yeah.
Well, of course, the cables go up through the centre spike, centre tube, connect up, and as it's wobbling, it's wearing the fucking live cable out, right? And there was no earth on the lights, was there? Right, no earthing on it. So of course the whole light become fucking live. And she went, look at the dust on them, right? And they've got a permanent live in these as well, right? So look at the dust on them. So she gets a damp cloth and goes up there and goes to clean it, fucking gets a right shock, right? But she survived. So my Caribbean holiday was put on hold. You know, I mean, I will try again, but there you go.
What make the cloth a bit more wetter?
Yeah, yeah. So it's things like that. Had that been earthed, and as that's wobbling around, that would have just tripped the RCD straight away. But it wasn't earthed at the time, and then I thought, yeah, I better put some earthing on these lights. You know, she's not a bad girl, really. I'll try and get rid of her another way.
So would the MCB not trip then?
No, it wouldn't trip because it's a live to earth fault, and MCBs only trip on load, live to neutral.
Yeah.
So it just means it would stay live, which it did stay live, and the fucking light worked well, and the fan worked well. I never used to touch it to turn the lights on. It was remote control. She just went out to clean the dust off it. I went, well, that'll fucking teach you. Leave things alone. So there you go. Sometimes, yeah, you've got all these different things, so you've got to have a little rethink. You've got to sort of visualise a circuit and go, what is changing resistance in here? I need to make sure I've got continuity flowing through the system. And I've got a stop-start button here. The earth goes all the way through, but the live doesn't. So, and when I press the button, it's not going through. Hang on a moment, how can I do that? Because some start buttons, if it's not powered, you push the button, it will not make the contact work. Okay? They need to be livened up to press the button and it will pull the contactor in. That button just switches the relay on, basically, and that pulls the contactor in. So sometimes you've got to link them out. Other times you can take the cover off, get a screwdriver and push the contactor in and hold it in. But that's no good if you're working on your own, doing that and trying to fucking take a reading at the same time. You know, so a lot of times, just a bit of cable, link across, take your readings, take them out, that's it. It's the only time I would allow you to put a link. Or, just test up to the fucking starter. Stop-start. After that, it's equipment. I'm not really interested in what happens after the stop-start button going to the motor, not really. I'm only interested in the supply coming in. That's the on-off switch for the motor. You know, so a lot of the time I'll just test that up to the stop-start button and that's it. After that, I'll just ignore it.
But what if the circuit continues after the stop-start?
If it continues, you've got to link it out and you've got to follow the earth all the way through, yeah. So you've got things like bypassing sensitive equipment. On the test boards up there, we've got bulkhead fittings as lights and they're LEDs. Now they've got LED modules on, and because we've got students up there fucking putting 500 volts on 10 times a bloody day every day, I thought, do you know what, it could fuck them up and we could get really bad readings in the end. So I've just installed little switches next to them. So when you do an IR test, you just turn the switch off and it just bypasses the LED module, which I don't really want to be testing the equipment. I want to test circuit, okay? That's why, as installation electricians, when you wire up circuits, even if it's a first fix and you've run all your cables, just strip a bit of cable and have a quick test. Make sure you've got a bit of continuity. You know, just go and strip and put connector blocks in and tuck them all in the back of in the socket box for the plaster to plaster over the bloody things, right? And do a little test. Yeah, I've got continuity. R1, R2's all right, because once they're plastered in, you're knackered. If there's something wrong, you're knackered. So I always check as an installation engineer, whenever I put anything in, I make sure it works, even if I'm not going to come back for like 3 or 4 weeks to second fix it. I want to know that my cables are fine. And when I come back and it don't fucking work and I've got no continuity, I know the plasters have fucking cut one of my cables. And I'll find it and I'll have them and I'll go to them, no, look. I took a fucking photograph of the readings. This is the date that I tested it and I had continuity. You've cut the fucking cable. And I'll get them on it all the time now. Because what they tend to do, they're plastering away and them trowels are really sharp. Yeah. They go like that and they slice through the cables. There's no requirement to put capping on cables anymore. Capping, people go, oh yeah, put capping on it because it protects the cables. It's only there to stop the plaster cutting through it. Right? Once that's capped and it's plastered, You drill through the wall to put a picture up, you're still going to drive, even it's metal capping, you'll still drill straight through it and go into the cable. So that was capping, was just stop the plasterers. Nowadays, it's stud walls, isn't it? You run it in stud walls and they just put plasterboard over it.
I thought it was so the plaster didn't degrade that was the sheathing. I thought that was the idea of it.
Sorry?
I thought it was so the plaster doesn't degrade the sheathing. I thought that was the idea of the
That's
capping.
fucking bollocks.
Right?
Right? Complete bollocks. Yeah, that's the plasterers putting that out, you know, because they keep cutting the fucking cables, so they made us put bloody capping on it. Right? I've never ever seen in my life plaster degrade any PVC. It might over about fucking 500,000 years eventually, but there's nothing in plaster that's going to degrade anything.
Lime
Right?
in it. Lime.
No, there's nothing in it. No, nothing in it. The plaster now has got very little fucking lime in it now. It's shit, not like it used to. I mean, if you did a listed building with lime plaster, oh yeah, you've got to be very careful with that. I mean, you mix that up and stick your hands in that, it's like frigging acid. You've got to be very careful with that. That's what they're talking about. But the plaster nowadays is nothing. You know, it's just like a bit of bloody filler now. It's cracked plaster. You ask any plaster, they hate it. They hate it. Disconnecting stuff, dimmer switches. Right, you can't test the lighting circuit with a dimmer switch on because it's got a little coil in there. Because a dimmer switcher switches, and when you turn that round, it's altering the resistance. When you alter the resistance, you change the current, which makes the light go dim or go brighter. That's all it is. So you don't want to measure. You don't want to measure that. So you need to disconnect that. Just link it out. Just take the live out, the live in and live out, and stick it in a wago or connector block. That's it. Don't need to disconnect, take it off completely. You can test the circuit in parts, so you can do up to the starter, and then from the starter up to the motor, and then add those two together. That's an easy way of doing it. Still means you've got to take the cover off the starter. I don't like taking covers off the starters because the fucking screws fall out and I lose them, and they're really odd sized screws. Choice of test method depends on the complexity of the circuit. As I say, whether you're going to use method 1 to confirm your CPC or your earthing, or you're going to use method 2 will depend on how complex is the circuit. If it was your main gas and water, and you're consuming it as here, and your fucking water pipe, your mains water was there, I'll do that. If it's a long method, I might want to find a circuit with a live and earth in it that I can do it. You know, it depends. You'll know the best way of doing it when you're on site. It's difficult to replicate that in here. Okay. This is what I talk about when we're looking at a starter. Okay, that's the distribution board. You've got your live coming in, your earth coming in, and your neutral coming in. Okay, this is to the motor. Okay, so this is your live. Okay, this is a little coil. So the same live comes through here. So when I press that button, it energizes the coil. When the coil energizes, it creates a magnetic wave, right? And it pulls these shut. Double pole, live and neutral. Pulls them shut, so it switches it on. Okay? When I press stop, okay, and because I've pressed that, okay, it's livened it up. If I take my finger off the button, this goes down as well, the latching bit. And because that's down, the coil's on all the time, even with this off. With my finger off, the coil's on the time, it's latched. So when I press that, that goes down and joins across there. So the coil can come on, and it will shut those contacts. Yeah. Take my finger off. We've still got live coming through here. As long as that coil is energized, that's pulled in, that's pulled in, that's pulled in. So it's latched on. Only when I press stop and break the live to the coil, that will pop up, that will pop up, that will pop up. Right? So when you do your testing, you've got to test through this somehow. And it's very easy to pick this coil up. As soon as you go on a neutral, you're going to pick the coil up. As soon as you go on the live, you're going to pick the coil up. So what you need to do is the live coming in, test up, disconnect it, test up to there. The live going out, test out to there. Add them together. Or you can just take those two out and stick them on there and test all the way through. Because if you took the live and neutral coming in and put them straight onto there, none of this is connected now. Yeah? Can you all see that? None of that is
Where would you
connected.
get that starter and motor? Where would that be?
That will be next to a machine. It's a direct online starter. So it could be on the wall, you've got the machine there, maybe on a wall, you've got a bit of copets going into the machine. Some of them are actually on the machines themselves and the supply goes into the machine. What it will do is supply will go to an isolator and then from there into the starter. You must have an isolator local to the machine, always. Sometimes they're on the wall, sometimes they're on the machine.
What have you got, emergency stop on?
Emergency stop button is wired through this as well. Emergency stop button will be part of this, so this will come out going into a stop button and there, so the stop button's closed. If you bang that, it breaks this bit. That's all emergency stop button is. That will be wired into that. So you can have a direct online starter like that, and you can have a remote starter. So you might have a stop start button here and a stop start button over this end of the machine. It's just wired, connected. Just think of it as like a two-way light switch. That's all it is. That's all it is. And that, the remote one will just be a switch. That will have the coil in and the contacts in. So a lot of the time on machinery, you're pressing the start button, we've got 230 volts coming through here and the motor runs on 230 volts. I don't really want 230 volts going through the on-off button. So what you'll actually do, you'll have the neutral come down here and this will go into a little transformer, supplying a transformer, and this coil might be 24 volts. So when you press the button, you've got 24 volts running through the on-off button. But when you press it, these contacts close and allow 230 volts to go through or 400 volts to go through. So control is all about safety. Most control systems are 12 volt, 24 volt. A lot of them now are fibre optic. Yeah, you've got fibre optic. You press the button and it just takes the cover off the glass and it sends like ... to a module and that says switch the fucking motor on. That's it. And that is connected to a PLC, which is a programmable logic control unit, which is basically an electronic relay. And it just says switch it on. If you're ever doing testing machines, right, and it's fibre optic, take the fibre optic off, right, get a sheet of white paper, point at the white paper, press the start button. ... .. Fuck me, SOS, the Titanic sinking. Right? You'll see a little code, ... It'll flash like that. You'll get a book with a machine, look it up. Oh, fucking hell, the bloody, the fan's jammed. Take the cover off, oh, the fucking belt's come off and the fan's jammed. It tells you all the faults. It's very, very easy. You think it's complex, it's not, it's so easy. But people go, what's that fucking doing? Oh, fuck me, I can't see now. I don't do that, just point it on a bit of paper and just watch. And it'll go like that, and you write it down, look in the book, and it tells you what the fault is. Yeah. It's quite, yeah, it's quite easy. It's quite easy. I've done loads of fibre optic stuff. So when we're testing this, obviously we're going to measure the R1 plus R2 the starter, and then the R1 plus R2 to the motor. Add them together. Or you can link out the starter, right? Or you can just do an R2 test. So we can go from the distribution board and we can go there to the motor. Have we got continuity? Right, the long lead method. Okay, that's it. That's your continuity of your CPCs. Once you've done that, you can then carry on and do your line conductors. Okay, your line conductors. There's a few factors, right? Conductor temperature, that is important. Okay, temperature is important because it creates lower resistance when it's cold than when it's hot. So it's going to alter your figures. We're not talking about in here, I'll put the aircon on now and it's going to affect the figures. No, but if you go into a refrigeration plant, you need to be aware that your figures are going to be very, very different. Very different. And you have to allow for that. Okay, there are tables that you can look up the ambient temperatures. There are tables that the minimum working temperatures and what the things will be. It's very rare that you never come across where you'll be working inside a refrigeration plant and you've got to do testing. Very rare, because most of those places have their own maintenance guys, unless you become a maintenance guy, and in which case they'll probably do it at the weekend when no one's in there, and it won't be quite as cold. Simple as that. Conductor material, okay, resistance of copper is different to other materials. What other materials do we use as conductors?
Can you steal
You could.
conductor on a lamppost?
You could.
Aluminium.
Aluminium, we do use aluminium a lot. The overhead power lines are aluminium now, it used to be copper.
But silver and gold as well.
Yeah, silver, you can use nickel in it.
Lead.
Yeah, lead. When I was about 11, we were doing rewires, and my job was to go in and strip out the old lead cable in houses, right? And you couldn't just fucking lift one floorboard and pull it out, because the fuckers had pinned it